Right. So hello, good morning. That's Piotr talking to you. I'm just trying to make this training. It's a draft version, just to see how it, if they're missing things and everything. So I hope for your feedback, whomever is watching this. And the point of this training is talk a bit on the peripheral OPC-UA server construction for using different peripherals which are connected via SCA. So I thought a good starting point would be this slide, which a lot of you have seen in many places. So this comes from some presentation I was delivering, and just for your information. So where we're standing. So here we have, this is our on-detector thing, right? Where we have SCAs, then we have GPT links, then we have Felix ecosystem, and somewhere on the Felix or very close to Felix we have this SCA OPC-UA server. So this orange box is the SCA OPC-UA server, which a lot of you download from GitLab, and a lot of you know. And then what we stated on one of the slides and presentations is that whenever you connect more advanced things via CA, like separate chips. So let's maybe start, drawing this. So the situation here is that you have some sort of like ASICs here, right? Wow, this is really difficult to draw it, but you have some sort of ASIC here, right? And this ASIC is some sort of a chip, MTRX or whatever is on LTDB or with other experiment subgroups. And the situation here is you have this piece of electronics, and this connects to SCA via some protocol. So that could be I2C, could be GPIO, could be SPI, could be a lot of the other different protocols. Now, when you want to do this, and when you want to talk to ASICs via WinCC-OA, so from standard DCS integration, the most obvious path, which is just go this with OPC-UA directly to the OPC-UA server, and then further through SCA to ASIC, has a lot of bad problems which can't be really easily solved. And I don't really want to explain you what's the problem with this situation, but what we said is, in this situation you should construct a peripheral OPC-UA server, so this green box, and this green box takes the complexity of scheduling transactions that have to go via SCA towards ASIC, right? So it's this guy, the green guy, which actually would know what it means to, for example, configure an LTDB or configure another piece of hardware, and it knows different statements that have to go via SCA to do that, right? So just not to keep this picture too confusing, I'm actually gonna erase this thing here. And what we're trying to do here is we're trying to see how to make this, how to create this guy. And what you have to know is the starting point for you is, for sure, you have deployed this thing, right? So you have SCA OPC-UA server probably already configured with the config files. And just one thing to add here is, since I don't have your particular hardware and I don't have an access for this, but I still want to prototype and work on this, then what we do here is I will use a special mode which is called SCA simulator. Let me maybe just draw it for you. So I want this SCA simulator which behaves kind of like SCA, and when we use it we can prototype a whole lots of interesting things without the real hardware. This is what I'll be using in this presentation. Once again, the purpose is because I do not have your hardware. So the SCA simulator, you can kind of directly hook up via here, right? And okay, there are a few modes, but the one I'll be using is I'll be connecting to the SCA simulator via NetIO. So exactly like I would be doing for Felix, right? And the SCA simulator will not really know what seating, what type of ASIC is there, but it will accept all the I2C, GPIO, SPA transactions. It will return random data, but this is not a problem. Either way, I don't know what's the data which should come back from the ASIC. I just want to prototype things. Okay. So let's maybe try to kind of decompose those few steps. So Here's my shell. I have a few tabs, right? I have a tab where I keep my SCA simulator. I have a tab where I have SCA OPC-UA server. This is the version that you can download and which we have advertised, yeah? So it's version 1.2.0. Then I have a few tabs where I'll be constructing this peripheral server, which I called LTDB, and I should have mentioned this earlier that for this training I'm using an example from our colleagues from mostly from Marseille who work on LTDB configuration, but the same procedure actually applies to anybody doing ASIC via SCA, right? So let's maybe start from setting the right environment here. So first of all, I'm gonna set up a SCA simulator here. So SCA simulator comes from the SCA software, which you can download from GitLab. So I'm running this thing. Let's see if it works. Okay, I think it's already listening for connections. It behaves like Felix core essentially. So it's like a Felix core running on the same machine, and kind of, you know, behind this imitated Felix core, you have the SCA. Okay, it's accepting. It's waiting for connections. Will accept connections. Now I'm moving to SCA OPC-UA server. So the one again, which you can download version 1.2.0 from our colleagues from Marseille, and here we have a ticket where this was. So it's OPC-UA 1191, where this all was studied. I received a config file from Daniel and a kind of a procedure. You know, so in my understanding, they have some sort of board which has a couple of components like MTRX, like GPIO, whatever that GPIO is used to drive. I don't know. I'm not really aware of this. But this is the procedure. This is all I need to actually know to make this peripheral server. So in this ticket, there's a config file. I use the config file in here. So it's essentially this config ltdb.xml. I just made two small changes in this config file. So first of all, I commented all of the SCAs apart from SCA1 because, you know, I want to keep this concise. And the other thing is, if you look into this ltdb.xml, what I did is this SCA in the address field, and from your Felix connection, which was like PCEMF something, I just replace this with, you know, with localhost, yeah, and then and the port numbers which the SCA simulator have printed out on the screen, yeah. That's the only thing. Okay. So let me look at my notes here because I tried to kind of right. Okay, so I'm now running the OPC-UA SCA server with this config ltdb. Okay. So what you can see here, by the way, is this is the output from the SCA simulator. So in the SCA simulator already have seen some transactions towards SCA. So you can see the server is running. So right now, what I've done, if we look at this picture, is I have run this orange thing. Yeah, I have run this orange thing, and right now it's already connected to this red thing, which is the SCA simulator. Yeah, at this stage. Okay. So I have here the UA expert, our favorite diagnostic OPC-UA client. So now I'm gonna add a few servers. Well, I'm gonna start with the first one. So first with this SCA OPC-UA, and it has told me that it's listening for me, right? Click connected, and I can see my SCA Felix 1, which I think is what Daniel has been configuring here. Okay, so that is the address space of this SCA OPC-UA server, and here we see a number of things which have been configured by Daniel. And when we look at the programming or configuration procedure, I'm actually going to address only the first step here, which is, you know, the rest you can do by analogy. So it says the first step is init MTRX, and there's MTRX and some registers to be written. So I can go back to the address space, and indeed I see in this SCA, the first SCA, then we have MTRX, and then we have register 4, register 5, right? That's the information I actually really need. I see it's in the address space. Okay, that is very, very nice. So so I will start. So since it looks like I have everything ready here, I will start with the construction of this peripheral OPC-UA server, right? There's some training for, or shall I say that we create OPC-UA servers using a framework called Quasar, and this framework is for really quick creation of OPC-UA servers based on the model. So you have the modeling step here. I'm not gonna do like full training for Quasar. I think when you follow my steps, then you more or less should see what I'm trying to do here. So I'm going to my clone of Quasar here. Let me just check if I'm at the right version. Okay, I think I should. Let's do this from I don't know, 1.3.0 for example. That should be the right version. So what I do here is Quasar create project. So I'm essentially creating my new OPC-UA server, right? The green box. This is what I'm doing at the stage. I'm gonna call it OPC-UA lar LTB server, and I'm appending it number 2 because I already have the one which I prepared just for the training. So, but you should go without 2, right? Of course. So I'm creating this thing. I just created this project. I'm gonna cd into this, right? So I see some files coming from Quasar. I'm starting a new Git repo for this thing. I'm adding everything that Quasar have installed for me, and I'm just doing the initial commit, right? Okay. And at this stage, you should create a remote Git repo like on GitHub, GitLab, or whatever you use for your environment, and configure it as a remote repo in here. I'll not do this because this is just for training, but you should do this, and in Atlas we will insist that you keep proper remote repo. Okay, so the next thing is, so we have we have the files for our new OPC-UA server. And now a small disclaimer. So when it comes to the libraries to run OPC-UA business, so we usually use unified automation libraries or the toolkit, which is a paid product, and it's just one person, you know, which can use it and build. So for the tasks like development and everything, we use an alternative, which is called OPN62541. It's not really important. The statement to make here is we can, and what I show you in this training, we will use this open source variant of OPC-UA libraries, but this will not affect you in any way, because you can very quickly in Quasar switch from one to another. And let's keep the development in the open source version, and then when your project is ready for deployment in Atlas or somewhere else, we can use the paid version and create libraries, the binaries and execs which you can use in production, right? So I'm just anticipating some questions. What about UA SDK? You don't have to use it. We have an open source variant. So how do I do this with this open source variant? From a Quasar, my Quasar repo, I'm copying a file called open. What was the name? Oh, Quasar, of course. OPN62541 config cmake. In here, I'm gonna add this file, and I'm gonna do the following: set build config. Right, this thing. And then I'm gonna do something like, no, set build, no, not set build config, enable module, and it's gonna be OPN625 blah 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 compat, right? So this is the module which enables open source OPC-UA libraries, and on the branch pmaster, I think it's the right one for this exercise. Let's do it. Let's see what happens. Okay. Looks like correct. I'm gonna commit the changes up to now, so adding Open6 backend. Okay, good. Then what I'm gonna do here is, right now I'm gonna build this very empty initial peripheral server. So just for a quick recap, I'm still on the stage, like I'm on the green stage, right? I'm solely focusing on the green stage at this moment, right? So Quasar Pi build, I think that should be sufficient. Let's see. So I'm gonna pause the recording for a few moments. Okay, so the server apparently is built. You can see linking executable, nice. So I'll create another tab here. So this tab I'll use for building, and for compiling this tab I'll use for running. So I loosely call it LTDB run. It's a stupid name, I know, but still. It's stupid because, you know, it's not related to LTDB too much at this stage. But so how do I run it? First of all, where's the executable of the server? It's in build /bin, so you can see it. And before I run it, I have to run a command called symlink runtime deps, because there's some config files which have to be pulled in. So you just say yes. It created like 2 additional symlinks, and I think I would be almost ready to actually run the server. Besides, probably not gonna start because it's configured to run on the same port number like the main one, right? Yes. So now comes a quick hack. But you see it's already starting. We'll start it in a second. For this open source version, the port number actually is unfortunately hard-coded, and we will fix this in a small second, okay? So let's follow my points. Now we create a new Eclipse project for this server, okay? For this development. So I'm taking the path of this server. I'm going to my main workspace. I'll close the one which I use for training, for practicing, let's say, for the training. I'm creating a new C++ project, location, and I call it OPC-UA lar LTDB server 2, and that should be just a normal Linux GCC, yeah? Nothing fancy here. Okay, this is my Eclipse, and so I have a project, and probably the first thing to fix is this port number which I mentioned to you. Sorry, it's a bit maybe hackish. This will be improved. Anyway, I'm going to server source OPC server, and there I'm gonna find that should be, wait, yes, set server config, and in set server config I see this line 46, at least at this stage. I'm gonna change it to, for example, 5,841 instead of 4,841. I'm rebuilding once again my Quasar project, but it should be fast this time. Because it's just one file to recompile. Good. And I'm trying to run it once again, and voila! Looks like listening on 5,841. And here, so I'm back to UA Expert. Now look, here's the servers. The first one on the list is my SCA server. Now I'm trying the other one, and the other one running on 5,841, and that's gonna be our green box, our peripheral server, right? So I'm trying to connect. Okay, I manage. It's empty, or it just comes only with the default components here. But at least you can see I have 2 OPC-UA servers at this stage. Okay. What would be the next step then? Well, before I start working on design, I think I should actually commit some changes here, you know, with the port number and everything. So git commit port number adapted or something, right? Okay. Right. So now I'm gonna move from here to designing this green box. So in Quasar, you have this is a design-based environment, or this is like what's the proper name? Is like model-based architecture. You could say this way, or model-based engineering. So when you go to this Peripheral server Eclipse project, you see a design directory, you see design XML. Once again, I'm not gonna offer here like full Quasar training because this you can find somewhere else, but I'm gonna show a few steps how you do this, and I suppose lots of the steps will be very easy to follow by you. So in Quasar we have classes. The classes can have variables, methods, they interconnected, they kind of map to configuration files. There's a lot of interesting things going on here, and this information you put into design, right? And then when you make your structure for the server, then you ask Quasar to rebuild the server, and then it prepares places for you in the source code where you could put your custom code, right? So when you want to design a server like this, then you should at least have a bit of understanding what's the structure of your hardware, right? So we have this information coming from, let's go back to the ticket from Daniel. And by reading the information, so I'm not gonna go through this here, but by reading this information, what I understood is that we have the per SCA, sorry, not per SCA, per server, we're gonna have five SCAs, or maybe even more. But let's focus on 5 SCAs. So there's a LTDB. LTDB has 5 SCAs, and each of these SCAs is taking care of different components on the LTDB, right? On the group of LTDB components which come under the hood of 5 SCAs. This is what I understood from our colleagues. So just to make a quick drawing, essentially what I expect here is the following situation. Where's my pen? My pen is here. Okay. So what I see here is like we have LTDB, yeah, and then on this LTDB we have, for example, SC1, right? So this is my LTDB. Oh, blah. Okay, so I have SC1, and there I have some sort of component. So I have like MTRX, right, which goes into SC1. Then I have some IO pins, like digital, like GPIO, right? I don't really know what they do, but this is what I learned. Yeah, and then what I was told is actually we have, I don't know how to. So this structure, if I say that this is some sort of like a structure here, right? So this structure is kind of multiplied by 5 times. So we essentially have 5 SCAs, right? Of course, there's like MTX and some other things. I'm not really an expert here, right? But what I see from here is this already gives me some idea that there's some sort of hierarchy here, that there's an LTDB, and within the LTDB there's like a few SCAs, and within SCAs you see within, in the sense of data flow, you see like different components that kind of attach. So this kind of gives me an idea that I could possibly say that LTDB kind of, in the data flow sense, kind of owns SCA, and then SCA kind of owns those different components. So this sign is like the UML sign, like component ownership and everything. So this is my idea how to model this. Yeah, I'm gonna be using this information to make the model for my server. Okay, LTDB owns SCA, SCA and MTRX and stuff in here, right? Might be different in your case, might be completely different. it's per case, of course, right? So what I will do now is, well, I'll add this LTDB. Okay. So I go to my Eclipse. I'll go to my Eclipse. I have my design, and it's telling me that it can, you know, I can add a class. So I'm gonna add a class here, and this class I'm gonna call LTDB. Okay. I don't need this cache variable here. Okay. And before I start moving on with other classes, there's a very interesting tool in Quasar, very useful tool in this context. It's called visualization, design visualization. What you do here is you say generate diagram for me. So it's using this design XML, which we just edited, and creates a visualization essentially, which is placed in design diagram PDF. And I'm gonna open this right now. Okay, it's almost empty. You can only see at the stage that I declared like a UML like diagram with LTDB class, like nothing at this stage. Okay, so we have the class for LTDB, right? Going from this picture, I see the LTDB has multiple SCA, so I'm gonna add a class called LTDB SCA, right? LTDB SCA, and then I think we also have LTDB MTRX. MTRX, okay. And then we should establish, because right now I just add the classes and I just want to establish this information that, you know, LTDB is kind of a parent in some sense of LTDB SCA and internal everything like that. And for this I used has objects here. I have to say what's my root object of the server, and I'm gonna say it's LTDB. We can change it afterwards. So what I'm saying is, I'm saying the root of the server is class LTDB here. And look what, you know, if I quickly refresh my diagram, look what happens here. It's kind of starting getting shape. So I have the root of the server. It contains a number of LTDBs. So now by analogy, I'm gonna take LTDB. I'm gonna say it has objects which are LTDB SCA. Yeah. Then this LTDB SCA, I'm gonna say it has objects LTDB MTRX. Okay. I saved my design. I'm regenerating my diagram, and this is what more or less happened here. Hopla. Automatic, right? So this is the root of my server. It's saying it can contain many LTDBs, and each LTDB contain many LTDBs SCA, which I think is a fair statement, and you can later on restrict to up to 5 as the real case. And then each SCA can have, you know, MTRX and other components, which I'm not really gonna focus at this stage. I'm just gonna focus on MTRX to keep it more or less simple at this moment. Okay. And now we can actually build this server. Why not? Let's do this. So I'm again running Quasar build. Okay. So since I changed the design, it's like the full server which is regenerated. So as long as you don't change the design, then it's just recompiling the C++ files which have, you know, the implementation stuff. But since you change design, then there's more things to rebuild. But it should not be a big problem. So I'm pausing this until finished. Okay, so I think this server is now built, and before we start adding device logic, let's look at this this file here. So inside build, which you maybe need to refresh in Eclipse, and bin, and we have this config. And the config file is what specifies your runtime configuration for your server. And what it's saying us is we have the configuration, and now it accepts LTDB, which just for the sake of testing, I'm gonna add one LTDB right now, and I'm gonna call it, I don't know, like LTDB, just for fun. I'm gonna find much better name. Right, and then I can add LTDB SCA, so let's call it SCA1 for instance. And I can add MTRX, and I'm gonna call it MTRX for instance, right? So I have this config file, I have the build server. So let's try to run it now. Why not? So I'm closing the previous one. I'm running OPC-UA server, and it's listening on this 5841. I'm gonna go to my unified UA expert. So remember, the second server on the list is my Peripheral server, the green box, which we are constructing at this stage. I have to rebrowse the address space and look. Now I see LTDB and SCA1 and MTRX. It's of course empty, but I actually see this, which is already, you know, it's already a step forward. You can't argue with that. Okay, so let's move on. And in the next step, what I need to do is. What I need to do here is, and here maybe it's missing. So we have this LTDB MTRX, right? Class, and now, well, since we want to configure MTRX, right? Then I'll simply add a method. Of course, not in config, of course in design. So this I can close, right? So I have a class LTDB MTRX, and I can add a method. And this method I'm gonna call configure, right? So you know, when OPC-UA client's gonna call this method, it's simply gonna do what it says. It's gonna configure my MTRX over the SCA, over the things, right? And I need to add one more thing, which is I'm gonna say that I will have device logic for this class. So when I'm adding this, it means I want to tell Quasar that it should prepare like placeholders for my custom C++ code, in which I'll be writing what happens when a client calls this configure method. Okay, so let's see if this compiles. And again, I'm pausing until finished. Oh no, of course, or even before, of course, I have to like create the initial implementation for this device logic. So, for your information, if you don't know Quasar, it's those implementation files. The custom logic goes per class. So if I say I have LTDB MTRX and I have device logic which is per this class, then I have to, you know, generate the initial version. And maybe regenerate in future, which should not be a problem really. But what I'm saying, Quasar Pi generate device LTDB MTRX, and I think it's done it. How do you check it's done? You go to device, you go for example to include, and now you see the LTDB MTRX. And the same should be in sources, right? And what's important at this stage is, since those files, like any other device logic files, will contain like custom logic, which is big value, you know, which this is what you actually, you know, your intellectual property, then we should commit those files. And for this you can use a Quasar tool called check consistency with --ask, and I think it's gonna suggest that you should add them to the Git repo along few other files which we maybe even skipped. Okay, looks good. So Quasar Pi, sorry, no, git commit add device logic. Right, okay, it's in master. Now you can try to build it. Let's see what happens. Okay, since we have the server, so once again let's let's see how it looks on the diagram at the stage. And you can see now I have a method configure at the level of mtrx, and I'm running my server, and look what happens. So I'm rebrowsing my objects, and there's a method called configure, and I can call this method, and probably it's not gonna work. Yes, it says not implemented. Okay, that's pretty much obvious. And but just to show you, I'm not really selling any anything dishonest to you. I'm just gonna add like one message here to be printed, which would go via logit. This is a logging engine that you should use for your server. I'm gonna say here, sorry, log, you know, something like called configure, something like this. Let's see. That should be, oh no, sorry, the wrong thing. Build. We run it again. Okay, and now I'm gonna call this method. Of course, it's still but not implemented, but at least I see the message called configure. So we know how to quickly glue the custom code, which we'll later need to actually connect to the primary OPC-UA server and to call things. So I think we should say this concludes the part 1 of this training, of the draft version of this training, and I think so where are we? We are somewhere at this stage, right? So yeah, somewhere at this stage, and I think, you know, adding now the UAO client and stuff, that should be the second part of the training. So I'm gonna finish this at this stage and continue with the next part very soon.